everyone, welcome to the next session on operations research. In this session, we will discuss the concept of classification of fixed order quantity inventory models. Fixed order quantity inventory models are used to determine the optimal order quantity for inventory replenishment in situations where inventory is periodically reviewed and orders are placed in fixed quantities. These models help businesses maintain an appropriate level of stock while minimizing costs related to ordering and holding inventory. So, here we are going to talk about the optimal order that we have to place for inventory replenishment. And the inventory here is going to be reviewed periodically, and the orders are placed in fixed quantity. So we are not going to discuss about uncertain demands. So this will help you maintain some stock level, and there will be some minimum cost for ordering and holding of inventory. The most common classification of fixed order quantity inventory models is based on the ordering process and the assumptions they make about demand, lead time, and inventory level. So we will be talking about all the fixed order quantity inventory models here. The two primary categories of fixed order quantity models are: the first one is economic order quantity EOQ model. The EOQ model is the most widely known fixed order quantity model. It aims to determine the optimal order quantity Q star that minimizes the total cost of inventory, including ordering and holding costs. This model assumes, so there are a few assumptions over here. Demand is constant and known. Lead time is fixed and known. The cost of placing an order is constant, that is ordering cost. The holding cost per unit per period is constant. Inventory is replenished instantly when the order arrives. So these are the assumptions which are made in the economic order quantity model. The formula for EOQ is equal to root of 2 ds upon h, where d is the demand rate in units per period, s is the ordering cost per order, h is the holding cost per unit per period. So these are the three terms that we are going to use in the EOQ formula. The goal of the EOQ model is to find the balance between ordering too frequently, which increases ordering costs, and holding too much inventory, which increases holding costs. So EOQ is the optimal value between having ordering cost and holding cost. We will try to find an optimal value, because if you order more, then your holding cost increases, but if you hold less, then you will have to place order again and again. So what happens is the ordering cost increases. So we have to find a balance between the two. The next one is reorder point ROP model. The reorder point model involves setting a specific inventory level reorder point at which an order should be placed. This model determines the optimal order quantity and the reorder point based on demand during lead time. The reorder point is crucial in ensuring that the company doesn't run out of stock before the order arrives. So reorder point is a point where you are going to place your order. Say if the stock reaches a particular value, for example, say the total inventory that you want to have is 150, and suppose if the stock reaches 50, then what you do is you place your order. So every time you need to do that, this will help you to avoid stockout situations. Key features: demand is usually assumed to be constant or deterministic over time. Lead time is constant and known. The order quantity is fixed, that is EOQ, and is placed when inventory hits the reorder point. So these are the key features of the ROP model. Reorder point formula: ROP is equal to demand per period into lead time. And ROP is a reorder point, demand per period, the rate at which the inventory is used, and lead time is the time taken for the order to be delivered. So the time between placing an order and receiving the order is your lead time. This model helps businesses avoid stockouts by setting an optimal point to reorder. Quantity discount model. In some situations, suppliers offer quantity discounts, a lower unit price for larger orders. The quantity discount model extends the EOQ model to account for these discounts. It is used when the suppliers offer price breaks based on the order quantity. So if you order large quantities, you will have to pay less, but if you order smaller quantities, you will have to pay more. The key difference here is that the optimal order quantity is not simply determined by minimizing ordering and holding costs, but also considers the potential for cost savings through purchasing in bulk. So here the cost saving is also done by purchasing in bulk. Key assumptions: price per unit decreases as the order quantity increases. There are fixed ordering and holding costs. The goal is to balance the reduction in unit costs with the increased holding costs due to ordering larger quantities. So here the goal is to balance the reduction in unit cost with the increased holding costs due to ordering larger quantities. The model calculates the EOQ for each price break and selects the order quantity that minimizes the total cost, including both the ordering, holding, and purchasing costs. So, here you are going to determine what is the minimum total cost, which will include the ordering, holding, and purchasing costs. Part period balancing PPB model. The part period balancing model is a fixed order quantity model that seeks to balance the cost of ordering and holding inventory over time. It is similar to EOQ, but instead of calculating the EOQ based on fixed demand and fixed lead time, it uses a more dynamic approach to determine the best timing and order quantity by comparing the costs at each possible ordering point. So every time you place an order, you're going to check what is the cost and accordingly you're going to place an order. Otherwise, it is similar to the EOQ model. This model is less commonly used than EOQ but can be appropriate in some settings, particularly in more complex or changing environments. So in EOQ model, you do not take into account the changing conditions, but if you are talking about the changing conditions, that is a dynamic situation, then PPP model is better. Time between orders model. The time between orders TBO model is a fixed order quantity model that focuses on the time between orders. This model helps determine the optimal time interval between successive orders based on demand and cost. So here you are going to determine what will be the optimized time interval between two orders based on the demand and the cost. It assumes that inventory levels are reviewed at regular intervals and the order is placed when the reorder point is reached. So you have to again and again check the inventory level before you are placing an order. The formula is TBO is EOQ upon D. TBO is the time between orders and periods. EOQ is economic order quantity and D is the demand rate units per period. Production order quantity model EOQ with production. The production order quantity model is a variation of the EOQ model typically used in manufacturing environments where goods are produced and sold simultaneously. Unlike EOQ, where inventory is replenished in one batch, this model assumes a gradual replenishment during the production process. This model is appropriate when production takes time and the inventory is being replenished continuously as items are produced. So this is about production taking time, but the inventory is continuously being replenished. Key assumptions in this model: the production rate is higher than the demand rate. So you produce more than what is the demand. Inventory is replenished as goods are produced. So continuously you are going to add material in the inventory along with the goods being produced. The ordering cost, holding cost, and the production rate are factored into the total cost optimization. So when you're talking about the total cost optimization, you will take into account the ordering cost, the holding cost, and the production rate. The next one is two bin system. The two bin system is a fixed order quantity inventory system often used in environments where simple inventory control is required. It is primarily used in small scale operations or environments where a low level of automation is present. How it works: inventory is divided into two bins or containers. When the first bin is empty, an order is placed to replenish the stock. The second bin serves as a backup and ensures that there is no stock out while waiting for the order. So, what you do is you have two bins, you use the first bin. Once the stock is over from there, you place an order, but the work doesn't stop. You can use the second bin, which has buffer, such that your production is continued. While the two-bin system is simple and easy to implement, it can be inefficient in larger operations due to lack of integration with more advanced inventory management technique. So this two-bin system is actually a very basic model wherein you don't have any level of automation or technology being used. It is a very simple method. So it is inefficient when you have larger operations because of lack of advancement in technology. So here is a summary of the key models. EOQ, basic model for optimal order quantity to minimize the cost. Reorder point determines the point at which an order should be placed. Quantity discount model considers discounts based on order size to optimize order quantity. Part period balancing balances ordering and holding costs dynamically. Time between orders focuses on the time interval between orders. Production order quantity model, a version of EOQ for production settings. Two bin system, a simple inventory control method based on two bins. Each of these models is used depending on the specific operational and financial circumstances a business faces. So based on your business, you need to decide which of these models you want to use. So with this, I end the session. I hope you have understood this lecture. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.